So, now you've had the introduction to XML, and you should have some appreciation of what it's good for. Now let's take a look at XML and how it can be used to represent information that we saw in a database, namely the restaurant database that I handed out in our last class session. If you haven't done so already, pull up or print out the Restaurant XML document available as a PDF in the Session 9 Course Documents folder. The data in this XML document came directly from the restaurant database. I want you to be able to see two different ways to structure and represent the same information. Now refer to the document, and I'll talk through some of the highlights. So just like in the third YouTube video and the tutorial that came with your readings for tonight, the document opens with an XML declaration. All it says is, hey, this document is in XML. Could somebody please get an XML parser that will know what to do with it? Next we have our root element after a bunch of comments that I put in there. The root element basically says that this is an XML document that describes things known as restaurant. Everything within this root element tag describes something about restaurants. Our first, and in this document our only restaurant, is an Italian restaurant. It has three attributes which state that it is named Promo Grill, and it is located at 15750 Annapolis Road, and its zip is 20715. Now, within this restaurant, there's something known as a dish. And the first dish we're going to describe as eggplant parmesan, which as the attribute of price equals $12.95. Embedded underneath this dish of eggplant parmesan are other tags that describe the dish, its course, and recommended pairings. Once all that stuff is listed, the dish tag is closed. Now, I'm not going to point out all of the differences between this and the database tables because I want all of you to do some of that analysis on your own and get the discussion going on the message boards. I have a couple of differences in mind that I would like for you to see, so if I don't see those come up in the message boards by class time on Thursday, I'll reply after Thursday's class and tell you what I had in mind. But one of the message boards in which you may participate for session 9 is called Comparing XML and Databases. So either now or later, spend some time looking at these two examples or thinking through other examples of your own creation and get into the nitty-gritty of these two ways of structuring and representing information. XML for information professionals. So not only are there relationships between XML and databases, there are also natural relationships or similarities between XML and the concept of metadata. As was mentioned in the XML YouTube videos and also in that IBM tutorial that was your XML reading for tonight, the step before creating an XML document is the creation of a DTD or XML schema. DTDs and XML schemas serve the same general function as a metadata schema. They declare what things and what characteristics will be identified and described using these knowledge structures. And of course, the line between XML and metadata schema is obliterated by XML-based metadata schemas that are in use right now, most notably the Dublin Core. It's no accident that XML got adopted by the community who creates metadata schemas because there's a good natural fit between the two. Now, I alluded to this in the second slide of part 1 of tonight's session, but I'll say it again. The reason why you as an information professional have a stake in the realm of XML is that XML tags are metadata labels that get wrapped around pieces of data. Those pieces can be big or small, numeric, images, text, video, whatever. But as soon as that piece of data gets identified via a tag, it can be found by any program that can read that tag. And if it can be found by a program, it can be found by a person who is using a program. So XML becomes a mechanism for applying metadata, which adds structure to data and makes information retrievable. If you're interested in XML, there are books in the library and websites where you can read about XML's applications for metadata or library services. So now that we have a decent grasp on XML, we can take it to the next level and think about the semantic web. So as we've established, traditional XML is used to label via tags and organize via hierarchical structure data. The semantic web uses these concepts and takes it to a whole new level. The semantic web uses XML for its traditional purpose of creating tags and wrapping tags around raw data so that it can be identified and retrieved. These tags represent concepts. These concepts are known in databases as entities, and XML as elements, and on the semantic web as classes. And the data that gets tagged is an instance of a class. But the semantic web goes beyond XML in that its languages allow for the description of logical relationships among classes. This is the part that computer scientists refer to as the artificial intelligence component of the semantic web. Classes, their characteristics, and their relationships are defined in ontologies. And ontologies serve a similar function to a DTD or XML schema. Now let's get into your semantic web unit a little further, and you'll start seeing how these things work together. Here's a friendly and accessible video that introduces the semantic web. Watch this video and then come back and watch the next video in our sequence, which is part 3 in the session 9 sequence. See you in a few.